Hello, everybody. I'm happy to see this interest. And I think I wrote too many slides, so I will try to go a bit fast. Just as an introduction, well, I have been around in this community for quite some time, and mostly on the graphics stack, and you will see how that's relevant in a short bit, a bit everywhere. And in the last stages, more on GPU, kernel, and userspace drivers. Everything mainline, of course, Mesa, kernel. And since the start of last year, I moved into NPUs. And that's because I saw that what I learned, reverse engineering and implementing drivers for the GPUs could be very much applicable to NPU drivers as well, and would be a pity if nobody was using that knowledge in the community. And well, I work alone so far, try to help people to start getting started on this, basically. Where are we right now? If you want to do acceleration on the edge, you can use the GPUs that you have there, but you are not going to get much performance. It will be a lot of work to optimize for your model for that specific GPU. And so people want to use the NPUs, which are on the SoCs that they already paid for. Only that you don't have drivers in mainline. So it's what we already knew from the GPU when we didn't have those drivers in mainline. Ancient kernel versions, 5.10 is quite popular among SoC vendors. And well, those binary blobs, and well, which we know how it is, we don't know what is in there, and depend on versions of libraries which are often very, very old. We wouldn't have that in our products, but we have to. And there's a lot of things. I don't want to shame any companies, but there's horrible stuff going on. And well, probably everybody knows about this, but for completeness, I will go over this. How this situation is hurting people who are trying to make products which use NPUs. Their engineers have to forward port those drivers to their kernels because, of course, they are not going to use such an old kernel if they need to support their products for 10 years, 15 years. They then have to move to the user space, and those are blobs, which you don't really know what is in there, as I mentioned, and depend on libraries, all versions of those. It's a lot of work. And well, there's also a new thing, which is that we don't have here Vulkan or OpenGL. We have frameworks, there's a lot of them. Fragmentation is there already in the open source options, but then you have to use whatever the vendor offers you, and they will often try to add value, as they call that, so you have to use their own framework, which takes very different shapes between one and the other. And if you have several product lines on different SoCs, for example, that's a nightmare. If you want to move to a different vendor, you will suffer for that as well. And every time you rebase, maybe you have an upstream first policy in your company, and you want to reap the value that you have added to mainline or that other companies have added there, you have to do that again. And then fix the bugs, of course, etc. Getting support from the IP vendor. If you have a 10-year support policy, what are the chances that the IP vendor is going to support there all that time? Very low, because they will have maybe 4 or 5 generations of their hardware. They don't have such big teams. And it's just that. I mean, those blobs have a lot of stuff that you don't really know what is in there. But I can tell you that all the user space libraries I have looked at, they statically compile repeat JSON, some versions we don't know of. And you can imagine, that's a library which consumes stuff. There will be buffer overflows. The JSON libraries very, very often have a security holes in them. And you just don't know what version is there. If they patched it, you just don't know. You have to just carry that risk. So where are we right now? We have 4 machine learning accelerator drivers in mainline. Havana Labs, Intel VPU, which now is called NPU, Qualcomm AIC, The first and the third one are only for the cloud. Intel a VPU, it's more a desktop or that, but it's flexible enough. Maybe we'll see that going down to the edge. I don't know. And then there's NPU, which is the driver in mainline that interfaces with Vivante GPUs, which come from very silicon these days. They acquired that. And that can be used as well for the NPU IP because the IP has the same front end in the hardware as the GPU. And of these, only NPU really, if you have an SoC for embedded in edge, it's the only one that you will be able to use right now. I did that work for Vivante, and I have started work on a similar driver for Rockchip. I have started with a userspace using the out-of-tree kernel driver just to start somewhere. That's working. The userspace part is quite advanced now, and I have moved to the kernel driver. That's where we are. What is quite interesting is that if you go to the kernel mailing list, there have been so many attempts of companies trying to upstream their own NPU drivers, or maybe from some partner, and these are just some of them. I'm pretty sure that there are others, and you can see that people attempted, tried to realize to different degrees that they need to have an open source user space, because otherwise the maintainers of that subsystem in the kernel, when something breaks, they will have to debug it with the blobs. I mean, that cannot scale, of course. They are not going to accept that. And if they accepted that, they wouldn't be able to do their job because they would be wasting a lot of time dealing with these blobs. So, well, not a great situation. What can we do about that? What could be a good way of upstreaming a driver? Something that could reach users eventually. It would be good, right? So we have a new subsystem in the kernel. It's the Axel subsystem in /dev/Axel. It's based on the DRM subsystem. It's actually part of it. And well, the only idea, the only reason of why we have another directory in the device hierarchy is so that the user space don't try to render with it, which is something which happens. Unfortunately, there isn't a good way of probing beforehand if that render node is actually rendering anything, or if it's for a compute only IP. But otherwise it's like an DRM driver, and drivers are expected to use everything that the GPU drivers use there. And really, from the kernel point of view, a GPU and an NPU is not that different. What do? They basically pass command streams, allocate memory, so that user space and hardware can communicate, and there's some synchronization in there, and then there's some power management, etc. Some of the code drivers are expected to use is part of a DRM, but of course there's also other stuff outside of DRM, like defrag for scaling. You're also expected to use that. And this is something that I have seen vendors trying to mainline their drivers not really getting. Maybe they are a bit in shock because their legal department, or maybe the strategy of the company, goes very much against this, which they really believe that they are doing something very special and that they absolutely cannot open source their user space drivers, the compiler mostly. But they really need to have an open source implementation in user space if they want to see the kernel driver in mainline. So hopefully, eventually people will realize this is the case and see what they can do about that. And in user space, a difference with graphics is that we really don't have something like Vulkan or like OpenGL. So, and we have several frameworks, and some of them make it easier to have some backend which is hardware specific. TensorFlow Lite, I implemented that one precisely because it has the possibility of loading a shell library which implements a stable API that contains all this hardware specific code. Android as well has something like that. It's also a shell library. There's a stable API you can rely on. There's OpenXLA there isn't that much traction yet, but it's looking good. It's pretty similar to the others. Then there's PyTorch and ONNX. It would be great to support them, but they really don't offer this capacity of importing a shell library. So what would you do? You are expected to have your own backend inside their own repo. I mean, you cannot have all those compilers duplicated everywhere. And will you have a hardware-specific backend there that can load your code, which would be in a single place? You can do that, but then you are inventing your own shared library API, that delegate API that other people can load. So it's very not scalable. Hopefully this will consolidate at some point. And I believe that having drivers in mainline will help that, because if people are currently forced to use whatever stack the IP vendor provides, then there's no point in that as well. They are not able to agree on something which is common to all vendors. So hopefully this will improve. And as you can see, the drivers that are currently in mainline, all of them comply with this requirement, which is about having an open source implementation of the userspace stack. Unfortunately, I cannot point you to Mesa, as is the case with the GPU drivers. Each of them have their own. And as you can see, or maybe if you know that each of them are supposed to be used within a much bigger userspace stack that specific vendor offers the customers. You cannot just choose yours, maybe use the same framework for different hardware. That's not the situation currently. Now, in the last case, at Naviv, what is being used for these Avivante NPUs, it lives in a Mesa. And the userspace implementation, which is work in progress for Rockchip, is as well in Mesa. They share a lot of code. I will be talking about this a bit later. Hopefully, if we have more drivers for other edge-grade NPUs, they will appear here, and people will be able to use whatever framework they want with the hardware that they choose. So what is currently in Mesa? I pointed to this. We have already a TensorFlow Lite delegate. People just load that, and that delegate will instantiate the hardware-specific driver for the hardware that you have on your machine, if it's there. And I plan to add as well a front end for the Android, and then how. The functionality is basically the same, so I don't expect that to be that much work, but it's waiting for sponsors, basically. And OpenXLA, it's interesting. Let's see how much traction it gets, but should be also pretty easy to support. And those are the hardware in the dependent drivers. You have hardware-specific drivers in Mesa itself, and you can also use some facilities which are in Mesa itself, so that correspond to some facilities which are on the DRM subsystem in the kernel, like a gem for the memory management, imbuff for sharing buffers. There's the synchronization, fences, sync points, and it also has quite some infrastructure for compilers. So you can organize your code in terms of passes, etc. We are used to in other areas, in GPUs, for example. Something important to note is that Mesa 3D is the canonical userspace driver for all GPU drivers in mainland. There isn't a GPU driver in the kernel with a userspace, which is something else. I mean, and there's good reasons for that, because we have to share a lot of code, and the people maintaining the kernel drivers and the subsystem in the kernel just don't want to have to debug with your random implementation anywhere else in the internet. And we have all vendors working there. Well, all vendors that want, okay? So, but we have their imagination working directly. You have Intel engineers there, AMD engineers. NVIDIA even at some point have worked for whatever they needed from it. ARM are working there. VeriSilicon is not, unfortunately, maybe one day. And of course, once it's in Mesa, it's packaged everywhere. It helps you with some common code, There's something very interesting is the automated testing infrastructure based on GitLab CI. Do I have the time somewhere? No? Okay, thank you. So basically, this is very, very great because engineers working upstream from your companies, for example, are able to waste much less time because somebody else broke something else. The CI will have capped that probably if the coverage is good enough. But also when you rebase on new releases, this will have been tested up to a much bigger level than other subsystem, other functionality which is in mainline right now. Near, I talked about that. There's also some tools for performance, for example. You get a lot of that for free just for being in Mesa. And of course, you are part of a community. You get some infrastructure, sysadmins, release engineering, conferences where everybody get together to improve it, etc. If you wanted, you can just go there. In the first case, for very Silicon Vivante NPU, as you can see, that's in Mesa/Mesa, so it's upstream. It has been merged. Like anything else, it's being packaged right now because it got into the last Mesa stable release. For Rockchip, it's in my own fork. I'm still working on that. I will be able to merge that into Mesa only in, at the same time as the kernel driver gets into the kernel. Does your company has a NPU driver to mainline? For those that do, you have to understand that you have to agree to open source enough of the stack so that the people who are going to maintain that from other companies are going to be able to maintain it by debugging, figure out when something breaks, if it's their own fault, whose fault it is, what has to be fixed, so that they don't have to revert blindly things because your product might have been broken, which might be for other reasons than what is in the kernel, actually. And when you start writing, well, the kernel driver, you probably will have a kernel driver that has to support a very broad array of functionality that might not be what users will be actually using. There's, for example, simulators, FPGA versions of that, versions that never made into actual products. That probably shouldn't be mainline. And anyway, maybe you did a great job at a driver up to the standards in your community, in your company, but that probably doesn't match what mainline would work best with. So I really recommend starting to write a new one with just the minimum functionality, maybe support just a single version of your hardware, and move there step by step. I think you will save a lot of time. If you develop everything that you think the mainline will be very happy to accept, after a year send it there, you are probably going to have to go to the drawing board again and start from zero. And that's really shocking. It's very hard for everybody involved. And it just delays the acceptance in mainland by years. Let's avoid that, please. And as the canonical user space implementation, if it's in Mesa, you will benefit of everything I said before, but you will also be making the job much easier for the maintainers that are going to have to look after your own code in the kernel. And so, why not? You should have a very, very good reason to not have it in there. But I know that because of marketing or you think you are going to sell better, maybe you think it would be great to give to your customers something different. You want to differentiate like that. But that goes very much against working with each other within mainland. There's a lot of ways to differentiate, to give extra value to your customers, but probably that shouldn't get in the way of getting your driver in mainline. So I'm getting to the end. Hopefully the things that I would really like to convey in this talk is that people who are trying to make products using NPUs are really hurting by having to use all these out of tree, all those user space, all those wonderful frameworks. Some are very, very high level. you just want to run, accelerate on the NPUs, and you are having to use some tools to manage the data with which you will be training your model. I mean, that's why. The NPU drivers will come to mainline. I mean, it doesn't matter what the IP vendors do. It's happening. It will be there, either if they work there or not. So, I mean, if you don't share code, if you don't share documentation, if you don't participate in any way, this will happen anyway. So it's not an argument to not help out. And really, these NPUs are nothing special. It's really simple hardware, much simpler compared to GPUs. GPUs are done. The NPUs will happen as well. I know that these companies really see NPUs as a way to differentiate. There's a lot of hype. People in the community working with the kernel or with other graphics libraries like Mesa, for example, don't know anything about machine learning, so it's a bit hard to appreciate this. But once you see how the sausages are made, I mean, it's pretty clear that there's no good reason why this should be here, should be like this, especially on the technical side of things, of course. This will happen, and really, I mean, we want to help. We want for people to be able to use the latest kernels. I mean, we are putting a lot of work, a lot of money is going into that. It's really sad if you have to go back to 5.10, and then there's several features, several improvements you will not be able to use. Then afterwards, that impacts your user space as well. System depends, for example, on newer kernels, you will have to use something older, other things like that. Once you have to use the BSP, you will probably also have to use the binary drivers for the GPU, even if you would like to choose the open source one. But that's just how it is. So hopefully we can fix that. The ISP camera drivers, for example, we're making a lot of progress. ARM has its open source implementation out there right now. It will be a pity if we cannot use all of that. And that's it. Do you have any questions? Please. Maybe. Yes, I see those. Oh, yes.
So with the frameworks, have you looked at Intel's OpenVINO in addition to ONNX, etc.? Has that got a more stable API or?
OpenVINO?
Yeah.
Or, well, I know it's there. I have looked at it, especially for how it interacts with the IVPU driver in the kernel. But from my point of view, it's just one more. I mean, AMD has its own as well. Each of these companies have their own. I understand that there isn't a Kronos API for that they can use. Things are not as mature as possible. But of course, if you have several products based on several different hardware, you have to use each of these frameworks support that, so it's not ideal. For the edge, I think we see consolidation on TensorFlow Lite, so at least we can go that way. But of course, we have to be flexible, support what people are mostly interested in using, and when something which has more potential for consolidation appears, support that and move forward. But it's early days. Any other question? Okay. So thank you.